there's perimeters, and they're going to give you formulas on 107 common quadrilaterals. Those should be pretty familiar to you. Circumferences of circle at the bottom of the page, pi times the diameter. That's kind of interesting that a long time ago, that's how they got the definition of pi. Because I forget what, yeah, here it says Greek. Well, it was a mathematician a long time ago that discovered that if you laid out the diameter of any circle and its circumference, it always was pi times. And it's amazing how long ago that was discovered. And then it's a non-repeating, non-terminating decimal, so it's an irrational number. Now, they have on page 109, they're talking about areas of regions. And you can find the area of region by breaking the region up with squares and then make the squares smaller and smaller. Maybe you've done that in calculus, right?
Yes, we were doing that in calculus.
It's just due to the limit as the squares become infinitely small and you get the, and you do an integral then. So, that's, so you're familiar with that. And there's area of a rectangle on the next page. And then it says, anything that's congruent, has congruent sides, have the same area. And then a right triangle, it's the height of a right triangle is one of the legs, depending on which one you want to call the base and which one you want to call the height. And it's always 1/2 of it. Easy thing to forget. It takes it 1/2. And then if it isn't a right triangle, then it's base times the height, and the height's got to be from that base to the opposite vertex. Okay. So anything. So what we're going to do, we're going to look at
problems on the end of that
section. All right, so number 2, the perimeter. I don't know. I guess I'll just go through and do the problem because I don't know for sure what you don't know and what you know. It's on page 114. The perimeter, and that's a parallelogram. And the parallelogram that 2A, the opposite sides are equal, so. And they're giving us 6 feet. And 10 feet. So if we're talking perimeter, the perimeter is just 2 times the 6 foot, because this one and this one are equal, and then this one and this one are equal. So 2 times 6 plus 2 times 10, 12 plus 20, 32. And then the B, I'm not going to draw that out, but you just add those up, right? That's the perimeter. 4, it says determine the perimeter of each figure. So when they have those little, only thing I think that probably needs to be mentioned is on A. And it's just going to be the sum of those around there. But when that means that this is 3.1 and this is 3.1, right? And then these two lines like this, along with this, means that this is 8.5, right? So then you just add 2 times 3.1 plus 2 times 8.5, and then add the 7.25 with the 2.6. Now that B part, it just, the way it's drawn, it just does not show perspective to me. I don't know. You just have to go with what they tell you. It is. They're showing you this thing that has this thing. And if you notice, they got this one is equal to this one, and then they got this thing is equal to this. They got this is 2 centimeters, and they got this thing 2 centimeters.
Professor, the 2 centimeters goes to the part above.
I guess it's above.
Uh-huh.
So it's 2 centimeters.
Yes.
And then they got this height is 6 centimeters.
Resulting in 4 for the 2 opposite congruent sides.
Okay, so then this is 4, and this is 4. Okay, so then you get the perimeter. All right, 6. So then the next 6 is the pentamina, and that's a 5 connected squares where 2 squares are joined together on the along an entire side. And the A part is saying what pentaminos have the maximum perimeter. Give me one. One that's straight out like that. That would have the maximum perimeter. B1 says which one has the minimum. So what do you think? Perimeter. If you remember, anything that as close as you can make it to a square, it's going to be the minimum. You know, when you get, you know, a rectangle will have a lot more perimeter for the volume than a square. Square is the least. If you can do it, if you take it and you do the first derivative and find the maximum, you know, you take, you know, you'll find out that it's a square. The volume of, you know, something, and you take that first derivative, set it equal to 0, you'll find that your volume is going to be something that's a square always. And then it says generalize your results from problem 5. And so it says problem 5 says now you have Petromino, and that's one that has 8. So B, C is generalize it to the above. So 5A, maximum perimeter, but it's 8 sides. So it's going to be laid out 8 long. And then thing that 8 cubes to it has the minimum parameter would be what?
Rectangle.
Yeah, you want to go 4 and 4. And you can't do better than that. You can't make that a complete square, so it's got to be a rectangle. So 8. It says, suppose we form a square by arranging toothpicks as shown. Find the perimeter and area of the square. Notice that isn't there 7 toothpicks on the side?
Right. So that's how we're gonna measure it in
Yeah,
toothpicks?
yeah. So the perimeter is what?
28.
Toothpicks, right? It's 4 times 7. And then it says, suppose that we rearrange the toothpicks in the corners. Now the area of that. So we want to find the area. Okay, it's 7 times 7, 49. Toothpick squared, right? B. Now you rearrange it, and what's the perimeter? Notice you don't have any fewer toothpicks, do you? It's going to be 28 toothpicks around it. But now what about the area? Okay, it's a hot. How did you?
Yeah, how would you come by that area?
Because you're missing technically 4 less little squares of toothpicks in there. So you just take the area from the other one minus 4.
It's actually 44. Because, no, 49. No, it's 45 because there's 4 of those squares that are missing, and it's 49 total, and it's 49 minus 4. Thanks. It's 45 toothpicks. You see, there's a square in each corner out. Okay. Now you rearrange the toothpicks again, form squares with two toothpicks on each side. In each corner, find the perimeter.
Perimeter stays the same, we've proven that.
Yeah. Now the easy way to do is how many squares on each corner are taken out. You see there's 4 squares on each corner. So 4, 8, 12, there's 16 squares less. Okay, then D, it says, if the squares and the corners have three toothpicks per side, find the perimeter and the area of the figure. So the perimeter is still gonna be what?
Still 28.
28. Now each corner is gonna have what, 9 out?
Each corner of an area of 9. So it will be 13.
4 times 9 if you want. So what do we got? Is it 13?
Mhm.
So now it says, what pattern do you observe? Suppose that the original square had M toothpicks on a side. The small squares in each corner had N toothpicks on the side. Write a formula for the perimeter and a formula for the area. So the perimeter is going to be what? M toothpicks on the side. 4 times M. And the area is going to be M squared with that corner. Each one of those corners is N minus what? 4 times N squared. Right? So every time when it had 2, it was 2 squared is 4 in a corner, and then there's 4 corners. Okay, so 10. For each circle, the circumference is given. Find the radius and diameter of each circle down to the nearest hundred. So you're given the circumference, it's 12 pi, and they want to know the diameter, and they want to know the radius. What's the formula for circumference? Pi times the diameter. And so pi times the diameter equals 12 pi. Diameter would equal 12, right? And the radius is what? Half of the diameter, which is 6.
What formula is theta times d? What formula is that?
What?
What formula is theta times d?
Oh, it's diameter. Yeah, it's circumference of.
The circumference of a circle is pi times the diameter. Circumference, the formula is pi times the diameter, and the circumference is 12 pi, so you take pi times the diameter and divide it into 12 pi. So then B, your circumference is 15.87. So you're going to go pi times the diameter equals 15.87. So diameter is 15.87 over pi. So the diameter is what?
6.
Is it 4.9?
Yeah, 4.9.
guess when I did it with my calculator, it's 4.96. Ah, quit it. Now you're making it. I'm gonna have to look. When I did it, I got 5.05. Okay, and that's right. Okay, so it's 15.87 divided by 5.05. Then what do we do with, we divide it by 2, right? 2.53. Approximates. Okay. 12. It says a square and a circle both made out of wire enclose an area of 18.48. So we have a square. And both areas are 18 point. Area here is 18.45. It says, when the wire is flattened out, which is longer and by how much? So how are we going to go about doing it? We got to find the circumference, don't we? So, you know, there's side squared equals 18.45, right? So a side of that square is the square root of 18.45. So then the perimeter is what? 4 times the side, isn't it? So that would be the amount of fencing. Now we want to find the circumference, so we're going to have to find what? Diameter. The area, formula for the area is pi r squared. So if we go pi r squared equals 18.45, r squared is 18.45 over pi. R is square root of 18.45 over pi, and then the circumference, the diameter is going to be 2 times r, and the circumference is pi times the diameter. So we're going to have pi times 2 times the square root of 18.45 over pi.
for a number?
Well, this will just make one round off error when I do the calculating on it. One of them I have to go 4 times square root of 18.45, right? So that's 4 times the second square root of 18.45. And then the other one, I gotta go. It's gonna be 2 times pi times the square root of 18.45 over pi. So it's 2 times pi times square root of 18.45 divided by pi, wasn't it? So the distance around the square is longer than the circumference of that circle. So here it says which is longer and by how much. So what I'm going to do is I'm going to go on that, subtract this one, and enter on it. That's how much? 1.95. So oops, wire a round square is 1.95. What was that, feet or centimeters? Centimeters longer than wire around circle. Now, 14, it says, by counting squares and parts of squares, find the area of each figure. I guess I am not going to give you things like that because it tries my patience to do it. I can just tell you, the first one, 14a, is pretty easy to figure out. That one was 8 squares.
This is pretty easy too.
And you can see on the top if you cut the right hand on the top away and put it over on the left, you have 2 on the top, then 2 and 2. That's 2, 4, 6, and 7, and then that one off to the side. If you just flip the top one onto the bottom, you got 8. Right? I mean, it's a thing that looks too hard to draw. if you take this thing right here and put it over here, right? Then you got 2 on top, and you got 2 up here, 2 in the middle, 2 on the bottom. This one, that's 7. Then if you take this part right here and put it down here, then you got 8. Right?
Mhm.
B, that one's, B, the answer is 7.5. You can see 3 of them just straight away, right? I don't, you can get the 4th one by the lower right, taking that and flipping around and put it right in the thing above it.
Mhm.
And then you can take that thing on the top where it goes something like this, and it goes back up and then comes out and then down. If you take this much right here, and you flip it over and put it right there, then you got 2. If you want to do the mind exercise, you can do it. But then the 3rd one, I'm not gonna do it because I just don't. It's 8. That one's a little bit challenging. I figured it out once, but I wasn't able to quickly figure it out before I came to class. You can, if you want to spend your time on it, you can do it. The next 16, to find the area and perimeter of each rectangle. So, 16A. Now, notice that rectangle, the area is going to equal the length times the width, which is 3 times 8, right? And then the perimeter is 2 times 3 plus 2 times 8. And this thing is 6. 22. Is that right? Then the B, the area, when it says 3.25, so the area is 3.25 squared, right?
5.2, sir, not 3.25. 3.52.
352, okay. Dyslexic, huh? But that's the area, right? And then the perimeter is just 4 times that. Because each side is 3.52.
How's area going? 3.42.
See, each side is 3.52, and so it's a square.
Oh,
But it,
okay, you did squares. You just put the.
well, see, this is 3.52, and this is 3.52. So all you do is take this area, that one times that one, which is 3.52 squared. That's the area.
You didn't multiply the square. You just. Okay.
Okay. 18. Says the width of a rectangle is 18 inches less than its length. If the area of the rectangle is 1,440 inches squared, find the dimensions of the rectangle. So, so it says width 18 inches less than the length. So this is the length, this is the width, but it's the length minus 18, right? And then the area is the length times the width, where the area is at 1440. And then if we just do length and substitute in the width L minus 18, and we got 1440 equals, that's the area, isn't it? L squared minus 18 L. So how are we going to do that? We set it equal to 0, factor it, right? L squared minus 18 L. Then we have, I'm subtracting the 144 from both sides and setting it equal to 0. And then by trial and error,
There's gotta be an easier way than trial and error.
now, well, you can use the quadratic formula if you want, or you can use completing square. But it's 48 times 30. What? You can, no, you're just, let's see. You're trying to find the x-intercepts, where y is 0. So this is L, that's a minus. L minus 48, L plus 30. And then you're going to have L equals 48. You can't have L equal minus 30, but it turns out that's what the width is, right? So it's 30 wide, 48 long. Now, you know, if it seems kind of impossible, I mean, completing the square, you know, you take that, I mean, trial and error, you just go 2 times, you just factor it, right? 2 times 720, then you say, does 3 come out? 4, you know, 5, 6, you know, and then you'd be 5 times something, and the difference would not be 18, and you just go on up, and then you just kind of find it. And you'd only do things that factor evenly. And if it didn't, you didn't find it, then you just go to the next higher, you know, like 10 times 72, well, you still wouldn't be there, right? So you'd know you'd have to go higher.
Well, we know the factors have to be 18 apart.
Yeah, 14, 144, yeah, that's what I mean. So, I mean, you know you're not there yet. And you could try 20 times whatever that is, 70. Is that 72 or 720? 72. That don't work, you know, you just kind of go up till you finally found something, the difference was 18. And if you don't find it very quick, then always what I do, what I teach my college algebra people is do completing the square. The quadratic formulas, unless it's just real, it's got a whole bunch of decimals in it, and things like that, completing the square is easy. So 20. What happens to the area of a rectangle if we multiply both its length and width by 2? Well, the area of a rectangle is length times width. So if we multiply the length by 2 and the width by 2, then we get 4 times the original area, right? So it's area 2 equals 4 times area 1. And if you go 3, the 3 area, when you multiply both sides by 3, you're going to get 3 squared, right? This one is actually 2 squared. So area 3 equals 3 squared area 1. And then by 10, well then you can conclude if you got area 10, that's going to be 10 squared times area 1. And if you do it by n, it's n squared area 1. Okay. 22. Says suppose two rectangles both have areas of 144 centimeters squared. Must they also have the same perimeter? Centimeters squared. Well, one would be a square, 12 times 12, right? And another one would be 2 times 72, wouldn't it? This one, the perimeter here would be 48, and the perimeter here would be 4, and 2 times 7, 144, 148. And I mean, that's a problem that you do in calculus when you find the minimum of things. You take the first derivative, set it equal to 0, and find out what it is, and it's a parabola that opens up. You find out it's a square. So they don't have to have the same perimeter.
I thought a rectangle, one side has to be longer than the other.
What?
I thought in a rectangle, one side is supposed to be longer than the other.
A square is actually by definition a rectangle, but if you wanted to, I mean, you could make something a rectangle that would be 10 by 14.4, right? That'd be 144, and then the perimeter would be less than the perimeter of one at 272. Problem 24, there's many answers to that thing. So 26. Determine the perimeter and area of each of the following triangles, round to the nearest hundredth. So A, the area and it's all, it's a perpendicular distance from the base to a point in the height, so it's 1/2 of the base times the height. And the base in this case, for that height, is 6. So this is 3 times that. Then I multiply right. Area is 7.5 centimeters squared. And then it says perimeter. It's just going to be the sum of the 3 plus 5 plus 6. 14 centimeters. And the B, the area is 1/2 the base times the height again. So it's 1/2, the base is 6, and the height is going to be 3 square root of 3. So this is going to be 3 times 3 square root of 3, and I'm just going to leave it at, I'll leave it at 9 square root of 3. Centimeters, no, it's feet squared. And the perimeter is going to be 3 times 6, right? 13 feet. Now the C, once again, 1/2 base times height. So you go 1/2, and the height is at 2.6. And then the base is going to be 5. It's not 7.5, it's 5. And just extend that out so that you can get the height. So this is 1.3 times 5. I think it's 6.5 inches.
Professor, that will be the height from the base. You know what I mean?
Yeah.
I don't understand that.
Well, for a triangle, the base is the base of the triangle, and it's the perpendicular distance from the base extended to the point up, the opposite point.
So,
And so it isn't 7.5, it's 5.
Well, supposing we flipped that triangle over and made 7 base.
And the height would be, let's see,
You know, I don't mean to be a
no, that's okay.
pester,
I
but
mean,
it just doesn't seem right to me to extend the triangle and expect to get the proper results.
if you were using the base to be this 7-inch, then what you would do is you do a perpendicular distance from here down.
Right. And I would wager that
But then if you did this one as the base, this value right here, you'd have to extend this out. You'd have to come perpendicular down. And then this would be the base, this would be the base, and this would be its height. Just like when you do this one, you extend it out, be perpendicular from the point opposite, and then this is the base, not the dotted line, and this is the height. I can how can I show it? See, if, just logic, if you used this as a height and the sum of these two as the base, right? Then your base would be this long, and your height would be this much, and the area would be everything inside here.
You understand what I'm thinking though, right?
Yeah, I know it.
You're changing the actual shape.
Yeah, but see, you'd be too big by that much. What? Oh. Too